In this video, I'm going to show you how to connect a 1.8-inch color TFT display that uses the ST7735 driver to your Raspberry Pi Pico board and how to use it with CircuitPython. I will also share with you 3 simple programs I developed using this display to help you get started. If you are a long-time viewer of this channel, you know that I like this display a lot and I have used it in many of my Arduino projects. It is inexpensive and easy to use. At the time of this recording, it costs around $6. Add another $6 for the Raspberry Pi Pico board, and with just $12 you have a pretty capable and easy to use development platform. The display is a 1.8-inch display and has a resolution of 160 by 128 pixels. At the back, the display has an embedded SD card slot, which is a nice add-on. The display uses the SPI interface to communicate with a microcontroller, so we need to connect it to the SPI pins of the Pico board. The first pin of the display is VCC, so we connect it to the V-bus pin of the board, which provides 5 volts if it is powered by the USB port. The second pin is ground, so we connect it to a ground pin of the board. I connected it to this ground pin. The third pin of the display is named CS. CS pin goes to the CS pin of the board, which is pin GP18. The next pin is reset. Reset goes to the reset pin of the board, which is pin GP17. The next pin of the display is A0. A0 goes to the DC pin of the board, which is pin GP16. The next pin is named SDA. SDA pin goes to the MOSI pin of the board, which is pin GP11. The next pin is named SCK and we connect it to the S-clock pin of the board, which is pin GP10. The last pin of the display is named LED and we connect it to the 3.3 volt output of the board right here. That's it. If we now power up the display with a sample CircuitPython program already loaded in it, we can see that the display works. The connection is ready. Let's now go to the computer to see the software we need to make this display work. First of all, we need CircuitPython installed on the board. If you haven't already installed CircuitPython on the board, don't worry, it is very easy. Hold down the boot select button of the board and then plug it in your computer. On your computer, a new USB drive will appear named Raspberry Pi. All you have to do is to download the latest CircuitPython.u2f file for the Raspberry Pi Pico and drag and drop it in that new disk drive that appeared. That's it. In a few seconds, the CircuitPython interpreter is installed and we are ready to use the board. Next, we need to install some libraries for the display. Adafruit, the company that is developing CircuitPython, has developed hundreds of libraries for displays, sensors, and so on, and they have packaged them all together in this Adafruit CircuitPython bundle.zip file. All we have to do is to download this file on our computer and unzip it somewhere. Now, inside the folder, we have to locate 2 libraries in order to be able to run the scripts I have developed. First of all, we need a library for the display. Under the lib folder, we have to select the Adafruit ST7735R file. Be careful, there is also an Adafruit ST7735 library which won't work with this display. We need the R version. Now we copy and paste this file inside the lib folder in the disk drive that appears when we connect the board to the computer, like this. Now we have to copy one more helper library from the bundle using the same procedure. We need to locate the Adafruit display text folder and copy and paste it in the lib folder of the board as we did before. This library will help us display text on the display. The last library we need to copy is the Gates library from this GitHub repository. We need this library for the Gates demo I showed you earlier, so the lib folder will look like this. Now we are ready to use the display. I used Thony as the development environment at this moment. In order to use the board, we have to go to Tools, Options, Interpreter, select CircuitPython Generic as the interpreter, and select the port our board is connected to. Now we are ready to write our code in this window and then press the Run button here and the board will execute it at once, since CircuitPython is an interpreted language. I have developed 3 simple programs to test the display. The first one displays a colored frame and a text on the display. The second program loads 5 bitmaps that are stored on the board, as you can see, and displays them one after another. I just wanted to check how fast it can update the whole screen. As you can see, the display is pretty fast. The third example displays 2 gauges at the same time. As you can see, the board can manage that as well with no speed problems. Cool. As always, you can find the code of both projects in the video description. Now that we know how to use the ST7735 display with the Raspberry Pi Pico using CircuitPython, we have a powerful and inexpensive platform for future projects. Raspberry Pi Foundation promises that this board will exist until 2028, so we have a lot of time to tinker with it and make some cool projects. It is now easier than ever. Thanks for watching, I'll see you next time.